Hey, this is Boulevard Broken, and today I'm going to teach you how to solve SI-HTS. What is this mod? It's weird, but let's go over it. So, your job as someone looking over a heated political debate is to make sure we do not get into nuclear war. And the way you'll be doing that is changing the outcome of a very important coin flip. So first, we'll take the serial number and see where we are in the coin flip. So let's actually just keep this on top. Okay, cool. That's the back of my mic. That's probably why I sound weird. So if we look at our bomb, there's our serial number. So I put it at the top. This is the only edge work you need for the mod. So using the edge work, let's go back to the manual to see what we do with it. We're going to turn it to base 36 and take it modulo 5. So T is 20, base 36 would be 20 plus 9 is 29, 29 modulo 5 is 4. Z 26, 35, 0, 6 is 6, which is 1, etc. So I took all of these in base 36. Did a modulo 5, so subtracted 5 until it's 0 to 4, and now I have them here. And then I convert those numbers from heads, tails, and side. So a 4 is a side flip, 2 or 3 is a tails flip, and 0, 1 is a heads flip. Let's just move that so you can see. I could have chosen a better place for this, but obli-di-obli-da, as the Beatles said. And it turns out that we currently have 1 side flip, 2 heads, 3 heads, and 2 tails so far. And the way to prevent nuclear war is by both parties tying. I mean, it's a best of 7, so if you don't tie, someone wins. But luckily, these coins are a little fat, so they can land on their side. So, yep, right now we have 3 heads and 2 tails. So in order for a tie to happen in the 7th flip, we need another tails. Now, if you get these and you have 2 more heads than tails, or 3 more heads than tails, or all heads, whatever, you would cycle through these numbers. So instead of 0 or 1 being a heads flip, 1 or 2 would be a heads, 3 or 4 would be a tails, and 0 would be a side, it landing on its side. And if it's still imbalanced, then you would have 2 or 3 be heads, 4 or 0 be tails, and then a 1 be on the side, etc. And you keep going through those until you get either a difference of 1, a 1 greater head than tail, 1 greater tail than head, or a difference of 0 in which you need to make the coin land on its side. And of course, if none of them are valid, you just give up and you say there's been 3 heads and 3 tails. Okay, so now we know that we need to flip for a tails for there to be a tie. But how do we make a coin flip for a tails if we're not flipping it? Well, we've been noticing how they've been flipping, and we know things about the person flipping. So if we go back to the module, we know that they've been flipping with a power of 15, and judging by the map in the back of the room, we can estimate their height to be 182 centimeters. And using these, we can see exactly how fast, how high, and how fast the coin's going to flip for any of their flips. Okay, so exposition over, what we're going to try to do is understand all the different ways they can flip the coin. There are 2 ways they can flip the coin from their control, which is an underhand or a flick. They can do either, so you need to solve for both. So it'll just give, initial velocity for an underhand is half of power. Initial height for an underhand is 2 over 5 times the height. I've done these here for you because tutorial shouldn't be you looking at a calculator. I already looked at the calculator for you. But for example, the power of this guy was 15. And so the initial velocity of an underhand should be 7.5, half of 15. And the rotations per second of the underhand, 1/3, should be 5, which this all checks out. Now, important note, and this is also at the bottom, 1 centimeter is 1 meter. We will be doing our calculations in meters. And the reason is because we have to account for gravity later. So, even though the module said that it was 182 centimeters, we want to write our height down and do all of our calculations with height equals 1.82 meters. In fact, let's just put that there so we don't get confused. Okay, so now we have our velocity, height, initial velocity, initial height, and rotations per second of underhand and flick. Now that we have all of these, what do we do with it? Well, this is where we come in. You see, they can control whether they do underhand or flick, but we have a magnet we can increase or decrease the acceleration due to gravity from. So, using our knowledge of physics kinematics and knowledge of the amount of speed, the amount of acceleration the magnet adds, and knowing the quadratic formula, we can solve for how long that coin is in the air, and knowing the rotations per second, we can determine where it lands. I know, crazy. So, let's get started. So, we're going to need to know how long the coin is flipping until it lands, aka until the height, y, is 0, and we're going to need to know how many times it rotates. So, we have R, which would be RU or RF, rotations underhand, rotations flick, times the time. But we don't have the time. None of what we solved for has the time. But we have this equation, and we have our trusty quadratic formula. So, when this equals 0, when y of t being the height based on the time, when that's equals 0, that means that's when the coin lands. Well, that being 0 looks a lot like the quadratic formula. So we can solve for when a squared, this, ax squared, this, plus bx, this, plus c equals 0. We can solve for x using this. So I've already put it here. Negative b minus, it's plus or minus, but when doing the mod, minus will always give you the positive answer, which is the one you're keeping. The negative one doesn't make any sense. Why would we have a negative amount of time? So negative b minus the square root of b squared minus 4ac all over 2a. So what is a, b, and c? Well, it says here that a is next to the x squared, b is next to the x, c is next to nothing. Well, we can consider t as x for this situation. So 1/2 of a is our a. It's a little confusing, but just think of whatever comes next to x squared or t squared is a. So 1/2 of a is our a. So let's just fill that in. Oh god, I'm holding my mic because my mic stand broke. So this is going to be a little scuffed, but let's just do this. So right now, let's solve for normal gravity. And we will solve for other gravities later, but right now let's solve for just negative 9.81 meters per second squared. And because we have this 1/2 here, it needs to be half of that. So our a for the quadratic formula and not for this is negative 9.81 over 2. And in addition, we have this 2a over here. Let's plug it in. Now, the 1/2 here cancels with the 2 over here. So this will actually just be negative 9.81 if it will type. Because that would be negative 9.81 times 1/2 times 2. That makes sense. Now, what is b? Well, b is the one that goes next to the singular x, or in this case the t, and that is v naught, which is the initial velocity, which we solved for up here. So let's actually solve it at first for an underhand, flick, or rather an underhand throw of the coin at no interference with the acceleration due to gravity. So our velocity from underhand, VU, is 7.5. It's 1/2 times the power. So let's replace stuff here. Let's add our 7.5 here. And then where do we have another B? We have another one right here. So let's do a 7.5 there. Cool. So now we have negative 7.5 minus the square root of 7.5 squared minus 4 times A, which is all that, times C. Now what is C? It's y naught, aka the initial height. Well, we have that. It was some multiplier of the person who's flipping its height. So that's 0.78. So let's just put that in where C is. And we have one step left. Wow, I didn't think it would go that big, but it's okay. We can just make this bigger. What is R? Well, R is the rotations per second, which makes sense if we're solving for how much time. We want to know how much it's rotated to see where exactly it lands on. So we have that. That's a 5.0 right here. So let's put that where the R was. That's my Windows button. And now we have rotations times something that solves for time, and that should give exactly what part of the coin it lands on. And if we plug it in here, we get 8.103. And that's exactly what I have here. This is where it lands on based off of an underhand throw. That's the U I have right here. And no change on gravity. That's the N. Now that you've done that once, you're going to do it 5 more times. What's the reason for this? Well, you can either put no interference on gravity, increase the acceleration due to gravity, which would make the A here, acceleration, negative 9.91, or decrease, which would make it negative 9.71. And I'm not going to make you walk through all of that, but for example, for this I, you would have all the same stuff here, but I would change this 8 to a 9, that is increased acceleration, and this 8 to a 9. And then plug that into the calculator, whatever calculator you're using, and I would get this result. And then for decrease, I would change this 9 to a 7, this 9 to a 7, and I would get this. Now, I am missing the first number on all of these because the next step is to take that number modulo 1. What it means is just get rid of anything next to it greater than 1. So get rid of that 8. We're left with 0.103, 0.026, 0.182. These down here are based on the flick rather than the other hand. So for these, I would keep these as the... First, I would start out with no acceleration change. Make that negative 9.81. And then change all the other values. So like this one is B, which was the initial velocity. So that would be changed to a 6.0. 6.0. C would be changed to the height flick, which is 0.91. And this would stay the same, but the rotations would also change. The rotations from the flick is quite a bit. It's 25. And if we were to plug this in, let's just do it one more time. That would give 33.992. Get rid of the 33, we have 0.992. So that would be where on the coin it lands if it was flicked. That's the F, and no acceleration from gravity. So we have all these decimals. What do we do with them? Well, then we get to the final sentence. If my notepad would get out of the way, I want to keep this up. Let's just do this. Okay. So now we take these values and then we assign +1, -1, or 0 to them based on whether they land on heads, tails, or side. So any number between 0 and 0.22, 22 being the non-included. So from 0.0 to 0.2199999, whatever, that would be a heads. And we notice all of these were heads. Oh, my mic is struggling for life. And so is my, oh boy, everything is. Okay, so this would be a heads because it's between those two. Increase, same value, so that would still be a heads. And decrease, same range rather, that would also be a heads. Heads is -1, so for the opponent, so that's -1, -1, -1. If we take the average of these, which is the average of -1, -1, and -1 is going to be -1. But if you don't know how to take an average, you just add them all together and then divide by however many you have, which is 3. So the average of -1, -1, -1, that's going to be average value for underhand. Typing with one hand is fun. Is -1. And then let's get the average value of our flick. Average val, I should have written this out before, but that's fine. That's going to be, well, let's see, 0.992, that's all the way up here, that's a heads, which is a -1. 0.680, that's going to be a tails, that's in the middle here. So that's going to be a +1. And decreasing gives us a 0.310, which is also in the tails, which is also a 1. So that should give us like 0.333, whatever. Now we have the effective values. These averages are the effective values for each toss type. The opponent will choose the highest effective value for toss type, which means whatever has the most, the biggest number in the average, which is usually related to the most tails. But sometimes like side will beat tails, heads. But 0.333 is higher than -1. And because of this, we know the opponent will flick. And from the very top, we know that we need another tails to tie the module, or tie the coin flip race. So our answer will be one of these, either increasing or decreasing the effective gravity with our magnet on a flick. So what does that mean on the module? Well, we can choose underhand or flick. I'm going to choose flick. And this is no change in acceleration. This is decreased acceleration. The arrow is up, but that means that like there's a force on the coin going up. It's decreasing how fast it's going down. So that's decreased acceleration. The down arrow is increased acceleration. So let's click that, and that'll solve the module. That's it. And finally, if the guy's upside down, their Australian Prime Minister just changed the acceleration on the coin. Like if you choose increased or decreased, just change it from one to the other. That should explain it all. Just make sure you're always changing to meters, and remember your quadratic formula, because it's going to be useful in real life, kids. See ya. If I can